Hello, in this video we're going to have a look at solving linear equations. We're going to start off in this first video by having a look at some relatively easy examples and then going to get more difficult in later videos. So what do we mean by solving equations? Well, I've got an equation like this, x plus 3 is equal to 8, so I've got a variable, I'm going to have some numbers and I'm going to try and solve it. I'm going to try and work out the value of x that solves my equation. I'm going to end up with x equals something. When you have a look at the examples that we're going to have a look at in this first video, you can probably do them in your head. So you can look at the first one, x plus 3, what number do I add to 3 to get to 8? That's 5. Most of us are going to be able to spot that the answer to this is going to be 5. So the whole point of today's lesson is not working out what the answer is to these questions, because we probably can do them in our head, but it's making sure that we're laying our work out correctly and that we're using the right mathematical techniques, so that when we get onto the more difficult questions, we've got those techniques and approaches that we can use to solve the questions that we can't do in our heads. So there are two relatively short exercises that come with today's lesson. You could probably rattle through them really quickly if you just do them in your head. It's all about laying out our work correctly, making sure it's down on paper so that we've got those techniques in place ready for those more difficult questions. Right, let's have a look at the first one. So I've got an equation with my equal sign. So my equal means that whatever I've got on the left is equal to whatever I've got on the right. So this thing is in balance. So if I do the same to the left, if I added something into here and I add the same amount on the right hand side, my equation's still going to be in balance. Similarly, I could take the same thing away from both sides of my equation and it would still be in balance. So I've got 8 on both sides and I take 3 away from both sides, then I've got 5 on both sides and it's still in balance, it's still good. Similarly, I can double both sides up or multiply it by any number. As long as it's the same number that I'm multiplying both sides by, then my equation's still going to be balanced, it's still going to be good. I can also half or divide by another number, and again, as long as it's the same number I'm dividing by on both sides, then my equation's still going to be balanced and I'm still good. When we're doing the questions, we're going to be looking at the operation. So in this case, I've got a positive. I'm adding 3 to my x. I'm going to want to do the opposite operation to the one we've got here. So instead of adding 3, I'm going to be subtracting 3 for the first question. And it's really important. What I'm going to do is I'm going to describe what I'm doing for each step. So I'm going to draw an arrow on both sides of my equation and I'm going to describe what I'm going to do. So instead of adding 3, I'm going to do the opposite operation to adding 3, which is to subtract 3, and I'm going to write that in both places. Then I'm going to do it to both sides. So I'm going to take my x plus 3 and I'm going to subtract 3. Well, I'm adding 3 and taking 3 away. That's going to leave me with my x. The whole reason for taking 3 away is to get rid of this plus 3. So I'm left with x is equal to, my pen decides it wants to work, there we go, x equals, and I've got 8 and I'm taking away 3. So 8 take away 3 is 5, and we're left with the answer that we knew already. We knew it was going to be 5, but what we've done is we've explained the operation that we're doing. We're taking 3 away from both sides. If this goes wrong and you've explained that you're trying to take away 3 from both sides, chances are you're going to pick up a method mark in the question. So if you haven't done this, you won't get the method mark if this bit goes wrong. So if you explain what you're doing and get through to your answer, you're going to pick up your method mark as well as your accuracy mark, and underline it, so you're saying to the person who's marking it, finished, my answer is x equals 5. Right, let's have a look at the next one. X subtracting 2 equals 12. Again, we can probably do that in our heads, but we're going to do it, we're going to lay it out mathematically. So I've got subtract 2, so the opposite operation to subtracting 2 is to add 2. So I'm going to do that to both sides of my equation. I can draw my arrows, adding 2 to the right, and I'm going to add 2 to the left. Of x take away 2 and I add 2, that's just going to leave me with my x, so I can write that in. I've got x is equal to, on the right hand side I've got 12 and I'm adding 2, that's going to give me 14. 12 plus 2 It's 14, underline it because I've got my final answer. Don't forget on the right hand side to do the plus 2. Sometimes we worry about this, the take away 2 plus 2, and think about this, and then we just write 12. We forget to do this plus 2. So if it goes wrong, chances are we've just forgotten to do this operation on the right hand side as well as the left. So it needs to be done to both sides of the equation, otherwise it won't still be in balance. The last one's a bit trickier. I'm starting off, I've got 10, I'm taking away x, and I've got 7. I've got this minus x. These questions, when they go wrong, it's almost always to do with this negative sign. So if we've got negative signs in the question, it causes problems. So the first thing I want to do is get rid of this minus x, and what I'm going to do is I'm going to do the opposite operation to subtracting x, and that is to add x. And I'm going to do that, as always, to both sides of my equation. So I've got 10, I'm taking away x, and I'm adding x, so that's going to leave me with my 10. The reason for doing that was to get rid of the minus x that I didn't really want to have to think about. So I'm left with, on the left hand side, 10. On the right hand side I've got 7 and I'm adding x. Well, I can't do that in one go because I don't know what the value of x is at the moment. So I'm going to write it as my 7 plus my x. Now this looks very similar to the first question. I've got x plus something equals a number. Only difference is I've got this on the right hand side. Doesn't make any difference. I can still go through the same steps to solve my question. So what I've got 10 equals 7 plus x, so I'm adding 7 to x. So I want to do the opposite of adding 7 to x, which is to take 7 away. So I'm going to take 7 away from both sides of my equation. So on the left hand side I've got 10 and I'm taking away 7, that's going to give me 3. And on the right I've got 7, take away 7, so that's going to leave me with my x, which is why I took away 7 in the first place. So I've got 3 is equal to x. I could leave my answer like that, and chances are I will get full marks for that in the exam. They'd be really harsh if they penalised you. Sometimes though it's quite nice to write it the other way around, so you've got it as x equals 3, so 3 equals x, x has got to equal 3 as well, and just write it the other way around. Really harsh if they penalise you for not doing that though. I'm just going to pause there for a second. Okay, last couple of examples I want to have a look at. The first ones we're looking at addition and subtraction. These ones are similar, but this time we've got a multiplication and a division to think about. So the first one, I've got 4x. Remember, what I mean by that is 4 times x. I've got this invisible multiplication sign that I don't write with my algebra. So 4x is the same as 4 times x. So to get rid of the 4, because I want to know what one lot of x is rather than 4 lots of x, I want to do the opposite operation to multiplying by 4, and that's going to be to divide by 4. So both sides of my equation I'm going to divide by 4. And just like the first few examples, I'm going to describe what I'm doing. So both sides I'm going to divide by 4. 4 times x, so 4 times x, and then divide by 4, so I multiply by 4 and then divide by 4. I'm just going to be left with my x. I've done the opposite operation, so I'm just left with my value of x. On the right hand side I've got 16, and I'm going to divide it by 4. Well, 16 divided by 4 is going to be equal to 4, and I've got my final answer, x equals 4. The last one, this one we need to remember what we mean by this fraction sign. So if I've got x over 4, what I really mean is, let's write it over here, x divided by 4. The fraction line is just a division. So this is x divided by 4. So to solve this, I'm going to do the opposite operation to dividing by 4, and that's going to be to multiply by 4. So both sides of my equation I'm going to multiply by 4. So if I divide by 4 and then multiply by 4, I'm just going to be left with my x value. So I've got x is equal to, this time I've got 3 times 4, or 3 times 4 is 12, so my x value is 12. Once you've done these questions, you can always double check them. So for this one, if x is 12, or 12 over 4, I know I can simplify down. 12 divided by 4 is equal to 3. Divide top and bottom by 4, and I'm left with my 3. So it makes sense. Do your sense check once you've got to the end of each of your questions. Okay, your turn to get a little bit of practice, so have a go at the questions in the exercise. Remember, it's not about solving them. I'm sure you can do most of those in your head. It's all about laying your work out like we've done in the video. So once you've finished it, take photos of it, submit your work and hand it in. I'm looking forward to seeing those arrows, and looking forward to seeing one line for each of your steps. Okay, give them a go.